Next question is a photon of wavelength 4.4 into 10 to the power minus 7 meters strikes on the metal surface. The work function of the metal being 2.13 10 to the electron volt. Calculate energy of the photon, kinetic energy of the emission, and velocity of photoelectron. That is what is asked in this. So what all is given to us? Wavelength is given to us. They've given also what is the work function, which is 2.13 electron volt. From these two values, you need to find out three questions. One is energy, second is kinetic energy of the emission, and the last one is velocity, where 1 electron volt value is given in terms of joule also. So here, first thing that we will calculate is energy of photon. So energy of photon, which is denoted as E, is hc by lambda. We are using this relation because lambda value is given to us. So we are using this particular relation. Now for this, a lambda is given to us in meters, so conversion is not needed. It's going to be a direct substitution. H is Planck's constant, so 6.626 10 to the power minus 34 joules second into. Velocity of light is c in 3 into 10 to the power 8 meter per second by lambda value is given to us in the question 4 into 10 to the power minus 7 meter. Now 6.626 into 3 divided by 4 will give us 4.969 into 10 to the power. Now this will be minus 34 plus 8 plus 7 will give us, this is going to be minus 19 joule. Because meter and meter will cancel, seconds inverse and seconds will get cancelled. Final answer will be in terms of joule. Now here we are going to see as per electron volt, because the question here is asked in terms of electron volt here. Energy of photon in terms of electron volt and not in terms of joule. So here we can say from the question 1 electron volt is equal to 1.6020 into 10 to the power minus 19 joules. Therefore, x electron volt, we have to find that out, is equal to 4.969 into 10 to the power minus 19 joules. Now when we have to take out what is x in terms of electron volt, this will be equal to 4.969 into 10 to the power minus 19 joule into 1 electron volt divided by 1.6020 into 10 to the power minus 19 joule. Joule and joule will get cancelled. Here 10 to the power minus 9, 10 to the power minus 9 will get cancelled. 4.969 divided by this will give 3.1017 electron volt. So that answers the first question, which says energy of the photon in terms of electron volt. Now the second question is kinetic energy of the emission. So here for kinetic energy of emission, which is the second one, energy of photon E equals work function, which is W naught, plus kinetic energy of photoelectron. Now work function can also be called as threshold frequency. So in this, what all do we have? Energy of photon we have, which we just calculated right now. We can also get what is the work function or threshold frequency. This is given to us as here in the question 2.13 electron volt, which is the work function. We need to find out what is kinetic energy, which is the second question in our entire question here. So energy of the photon is this 3.1017 electron volt equals, work function is in the question 2.13 electron volt plus kinetic energy of photoelectron. So therefore we can say kinetic energy of photoelectron is 3.1017 minus 2.13, which will give answer 0.9717 electron volt. That is going to be the kinetic energy of photoelectron, which is the answer for the second question here. Now we need to find out the last question, which is for the velocity of a photoelectron. Now for the last one, we are going to write here, we can say kinetic energy of photoelectron equals, what value you found out now? 0.9717 electron volt. So here we can say, as per the question, that 1 electron volt is 1.6020 10 to the power minus 19 joule. That's given to us in the question. So here we can find it out using a formula. Now if you want to know what is the velocity, which is the third question, we need to find out what is the kinetic energy as per that value. So here we need to convert that kinetic energy into joules, because here it's given as electron volt. So here we will write that 1 electron volt is equal to 1.6020 into 10 to the power minus 19 joules. So here when we write our answer, we will write therefore 0.9717 electron volt is equal to, multiply these two, divided by 1 electron volt, 610 10 to the power minus 19 joules into 0.9717 electron volt divided by 1 electron volt. When we simplify this completely, we will get 1.556 into 10 to the power minus 19 joule. So what we did right now is, whatever kinetic energy we got in terms of electron volt, we just converted it to joules. Now what we will do is, we need to find out what is the velocity. But that velocity you will get only from the kinetic energy formula. So here we can write that kinetic energy is equal to 1 by 2 mv square. Now V is what we have to find out. Kinetic energy we already have here. Here mass is photoelectron, which means the mass of electron. So therefore mass of electron is equal to 9.1 10 to the power minus 31 kilogram. That is a standard value. So this is going to be the value for this. But if you see, our energy is in terms of joules, this mass is in terms of kg. So we have to convert this in terms of kg also. So here we can write that 1 joule is equal to kg meter square seconds minus 2. So now if 1 joule is equal to this much, this many joules, only the unit will change here. So let's substitute the value in kinetic energy is equal to 1 by 2 mv square. So for that I'm going to write here, this is going to be kinetic energy is 1.556 into 10 to the power minus 19 kg meter square seconds minus 2. That is a kinetic energy in terms of kg. This is equal to 1 by 2 into mass of electron is 9.1 into 10 to the power minus 31 kg into v square. Now v is what we have to find out. So here v, now in this case v square is equal to, we have to cross multiply 1.556 into 10 to the power minus 19 into 2 divided by 9.1 into 10 to the power minus 31. So here we are going to find out v square, or v square is equal to 0.3421 into 10 to the power 12. Out of these two values, kg and kg will get cancelled. What you're left out is meter square seconds to the power minus 2. Now v square is given. We need to find out what is v. So v is equal to root of 0.3421 10 to the power 2 meter square seconds minus 2. Now this 10 to the power 12, I'm going to just simplify it. So here 10 to the power 12 can be written as 10 to the power 10 plus 2. So here this will become 10 to the power 10 into 10 to the power 2. So this will be 10 to the power 10 into 100. So when we do into 100, this decimal will move 2 places. So 1, 2. Now this will be equal to root of 34.21 into remaining is 10 to the power 10. 10 to the power 10 meter square seconds to the power minus 2. Why I did this method is to simplify my root here. Now simply take the root of this. This will be equal to 5.848 into 10 to the power 10 to the power 10 will become 10 to the power 5. Here all the squares will get cancelled. This will be meter seconds inverse. So this is going to be the velocity which is going to answer the third question, which is the velocity of a photoelectron.